Okay, so I'm on page 58 in our book, example 2, compose two functions. That's page 58. Example 2, compose two functions, and I am looking at guided practice number 2A. And so we are being asked here, we're given two function values. We got f of x equals 3x plus 1, and then we also have g of x equals 5 minus x2. And so we're being asked to compose both f of g and then g of f, and then a little later on we're asked to compose f of g 3. So let's just go through here. So what we're doing, let's start here on the first one, this f of g right here. So I substitute in for x, g of x, 5 minus x squared. So now I've got 3 parentheses 5 minus x squared plus 1. I distribute the 3. So I now got 15 minus 3x plus 3x squared plus 1. And combine like terms, and I end f of g is minus 3x squared plus 16. Now on the g of f, we do something very similar, except now we're going to substitute in for x and g of x, f of x, 3x plus 1. So here we go. We start off right here. G of f equals 5 minus 3x plus 1 squared. Now, you're going to need plenty of paper when you're working these f of g, g of f problems, because there's always something like this. And so what I often do, so I don't run out of paper, I may drop this foiling to square this 3x plus 1 down to here, just so I can kind of organize myself so I don't go completely crazy. So now I'm going to FOIL or square 3x plus 1. And of course, that's going to give me 9x squared plus 3x plus 3x plus 1. I combine like terms. I got 9x squared minus 6x plus 1. Plug it back into my original equation. But if you notice on this one, I've got a minus there. So I got 5 minus parentheses 9x squared plus 6x plus 1. I got to distribute the negative 1. And when I do, I'm going to end up with 5 minus 9x squared minus 6x minus 1. And now I'm going to combine like terms, and I got my final answer of minus 9x squared minus 6x plus 4. And then I'm asked to substitute in 3 for x in what I solved right up here as f of g. Easy enough. So now I've got minus 3 times 3 squared plus 16 minus 3 times 9 plus 16 minus 27 plus 16, and my final answer is minus 11. Composing two functions. Ah, how sweet it is. Okay, well, I'm still on page 58. I'm still looking at example 2. I'm at the bottom of the page, but now I'm on guided practice 2B. And so we are given two function values. I got f of x equals 6x squared minus 4. And I'm also given that g of x is equal to x plus 2. So let's start on the f of g. So I've got 6, and I'm going to substitute in for x, the x plus squared from the g of x right here. Okay, so I got 6 parentheses x plus 2 squared minus 4. I am going to square the x plus 2, which you can see here. I came right down here to do that. So x plus 2 times x plus 2 equals x squared plus 2x plus 2x plus 4. Combine like terms, x squared plus 4x plus 4. Then I substitute in back up here after I have squared x plus 2. Come right down here, and I'm going to first distribute that 6. So I've got 6x squared plus 24x plus 24 minus 4. Let's combine like terms, and f of g is 6x squared plus 24x plus 20. Somebody gave me a phrase the other day. Are you picking up what I'm putting down? All right, how about g of x? Well, they kind of take pity on us on that, since they made us use about half a page to solve the first problem. And so I've got g of x. G of x is x plus 2. I'm asked to find g of f. And I just simply substitute in for x, the 6x squared minus 4, coming back from right here. And now I've got 6x squared minus 4 plus 2, combine like terms, and I end up with 6x squared minus 2 is g of f. And then finally, we're asked to find f of g when f of g is 3. And so again, I just simply substitute in 3 for what I got right here. Drop it down here. 6 times 3 squared plus 24 times 3 plus 20. 6 times 9 plus 72 plus 20. 6 times 9 is 54. 72 plus 20 is 92. 54 and 92 is 146. And so f of g, when that is 3, is 146. Okay, somebody's got to give me a new saying, but are you picking up what I'm putting down? Okay, I'm now on page 59. We're looking to find a composite function with a restricted domain. And I'm on example 3. I'm looking at the guided practice, and then I selected one more. There's 2 of the guided practice problems, and then I selected one other for us to take a look at. So let's look at the first one, which so it gives us that f of x is equal to the square root of x plus 1, and g of x is equal to x squared minus 1. And so just like we did before on f of g, I'm going to substitute what the function value or equation for g of x, x squared minus 1, into f. And so that's going to give me x squared minus 1 plus 1, and which is just going to be the square root. It should be x square root of x squared minus 1 plus 1. And that's just going to give us the square root of x squared, which of course is x, or specifically plus or minus x, or we could express this as the absolute value of x. Now, in this case, we actually would not have any restrictions to the domain, because no matter, although we would be on guard to look to see if we were about to take a square root of a negative number, since we end up with just the square root of x squared, whatever negative number x may be, it's going to be squared. It's going to make it a positive number, and therefore there's no restriction to the domain. So let's look at this second one. Now on this second one, we have f of x equals 5 over x, and g of x equals x squared plus x. So again, we're going to do f of g, so it gives me 5 over x squared plus x. Well, that's the end of the calculation. Now I just got to think about, okay, what could be a restriction to the domain? Well, we know our overall restriction is that we cannot divide by 0. So obviously, if x were 0, 0 squared is 0 plus 0. Well, that's 0, so x cannot equal 0. And if I look at that even more closely, if x were negative 1, well, negative 1 squared is 1 plus negative 1, because I'm substituting negative 1 in for this final x right there. That'd be plus 1 minus 1. It's going to give me 0. So the restrictions to our domain are that x cannot equal 0 and x cannot equal negative 1. Now, this is another one that I picked up. This is actually one of the problems in what will probably be assigned as homework. And here we see that f of x is equal to x squared minus 9, and g of x is equal to the square root of x plus 3. So we start off with f of g. We're just going to substitute in this square root of x plus 3 for the x squared. And so now I've got the square root of x plus 3 squared minus 9. And obviously, squaring the square root of x plus 3 is just going to leave me with x plus 3 minus 9. And that means that f of g is equal to x minus 6. Now, obviously in my answer here, I don't have any I wouldn't have any restrictions to the domain. And whatever square root I'm doing here, right here, would not in and of itself give me a restriction to the domain. What does give me a restriction to the domain is I got to look back here to g of x. And there, when I'm looking at the square root of x plus 3, I can't take the square root of a negative number. So what would cause me to have a square root of a negative number? Well, that would be if x was anything less than negative 3. So my restriction to the domain is x must be greater than or equal to negative 3. So negative, obviously, if I plugged in negative 4, right back up in here, well, that would be, I'd be trying to take the square root of negative 1, which I'm not allowed to do when I live in real number world. And thank goodness we are in real number world and not imaginary number world. Okay, so that gives you a few examples of finding a composite function, the value of a composite function with a restricted domain. Well, let's look at the last couple of examples here in this chapter of what we're going to deal with as far as operations of or function operations and composition of functions. And this, I'm on page 60 now. This is on example 4. Again, I'm at the bottom of the page. I am looking at the guided practice. And here this is where we're going to decompose a function. Now, these are not that hard. They kind of look harder, maybe some when you start out than what they are. You really just have to kind of think for a moment. Well, if you'll sit there and think, you can usually see your way through it. And we will be decomposing functions every now and then as we go along. So it is a skill that we need to learn how to develop. So here they've given us a function value. And they're saying, okay, h of x is equal to x squared minus 2x plus 1. They're asking us to decompose that, or basically what are they saying is what two functions combined can give me a function that it would equal x squared minus 2x plus 1. So if I focus on this right here for a few minutes, a few seconds maybe, hopefully, well then I can see that x squared minus 2x plus 1 is in fact factorable, and I can factor it into x minus 1 times x minus 1. If you FOIL that back, we're going to get x squared minus 2x plus 1. So now that I know it's factorable, well then I can come up with a sample answer or put together a scenario of two functions that I could combine and come up with this x squared minus 2x. So if I had to say, okay, I say, well, f of x could equal x squared, and g of x could equal x minus 1. And if you think about it, if f of x was x squared and I was doing f of g, I substitute in x minus 1 squared, which is exactly what I have right here. I proved it right there, and therefore I have decomposed the function. Now, second one is where we have this one right here, where we've got h of x is equal to 1 over x plus 7. That one's probably a little easier to sit there and think about and figure out, because I could say, okay, well, f of x could be 1 over x, and g of x could be x plus 7. And if I compose those or combine those, well, then I'd end up with h of x. If h of x was the composition of f of x, or f of g, I should say, f of g, then I would have 1 over x plus 7. Decomposing functions. Decomposing, that's something to think about. Okay,